if you put it down here, these will be 0. So anything by 0 is undefined. So we need to do the chart. So we are putting the limit to the left, and then limit to the right, and then these will be undefined. So we need to take the limit, substitute this one here, and substitute this one here.
Problem 4. So, we will have to erase this to make space so we can substitute. Okay, so the first thing we're going to substitute in the equation to find the limit of x, that is 4 in this case, is going to be limit x of x4 equals to 3.999 squared plus 5 times 3.999 minus 36 over 3.999 squared minus 7 times 3.999 plus 12. Now we can plug this into the calculator to get our results for this limit. So plugging in the calculator. We have finished plugging it inside the calculator, and our answer is 13.012, which we can add over here. Now we have to plug in 4.001. So what we'll do is limit equals, and x limit 4 is, when plugged into the equation, 4.001 squared plus 5, 4.001 minus 36 over 4.001 squared minus 7, 4.001 plus 12. Once again, we must plug it in inside the calculator. So we have plugged it in, and the answer is 12.988. So we put it over here, and now we have to round both numbers, and once rounded they will both equal to 13. So they are the same. So the answer will be limit x, which is 4, is equal to 13. We graphed problem 4, which was an equation we had to evaluate numerically. We had to find the limit of x at 4. The answer we got was that the limit of x4 is 13. So once it's graphed, as we can see in the graph, it is clearly shown that the limit of 4x is 30, which is a point in the graph is 4,13.
Today I'm going to do the problem 81, which is to find the tangent line. So first you need to substitute in the x you have here. So here it's f2 equals 2 times 2 squared minus 5 times 2 plus 1. So here is 2 squared 4 times 2 minus 10 plus 1. So it's 8 minus 10 plus 1, and the answer is y equals 8 minus 10 minus 2 plus 1 minus 1. And then you have to find f prime. So it's the exponent, which is 2 times times this 2 is 4x, and then the exponent minus 1, which is 1, and then minus, and here the same, 1 times negative 5 minus 5, and this one deletes, and this one also becomes 0. So then you have to replace again the x equals 2 in here. So it's 4 times 2 minus 5. So it's 8 minus 5. So the slope is equal to 3. So here you have both, and then you use this formula and you just plug it in. So it's y minus y1, which is minus 1, equals m, which is the slope, it's 3, and then x minus, and the original x, which is 2. So this one turns positive, and then you do FOIL. So it's y plus 1 equals 3x minus 6. And you just pass this one over there, so it's y equals 3x minus 6 minus 1, and that is y equals 3x minus 7. And that is the answer.
We graphed problem 81, where we found the tangent line for the original equation. In this graph, we can see how the answer we got, that is the tangent line, meets with the original equation from the beginning of the problem, which makes it a tangent line, since the tangent line only touches once on the other graphed equation. In this case, our tangent line was y equals 3x minus 7, and the original equation was y equals 2x squared minus 5x plus 1. We had to solve for the tangent line at x equals 2.